Good morning, everyone. We're just gonna give a couple of minutes for people to log in, register and log in. All right, I see that people are joining us. That's great. And I hope everyone can hear me all right. So we're ready to start, I think. So good morning, everyone, once again. Thank you very much for joining us today. My name is Renata Barros. I work at the Geological Survey of Belgium, and I'm the coordinator of the GeoConnect³ project that is organizing this webinar series this week for you. I'll be your host today, and I'm very, very excited to kick off with our event promoting geoheritage and geotourism, because these are very, very interesting topics to explore for sure. And we have 3 more webinars coming up, all of them from 9:30 a.m. Brussels time. You can still register on each event page, and the link will be there in the chat for you. But okay, so this is an overview of what we're going to have today. We have 3 great talks to look forward to, and then we have a Q&A session and an interactive session as well. But for now, I just want to introduce the great group that we have here today. Sorry. So starting with our first guest speaker, Glenn Burridge. He's the Executive Director of the European Federation of Geologists. Hello, Glenn.
Good morning, everyone.
And our second guest speaker is Monica Souza. She's the Executive Director of the Portuguese Association of Geologists and the coordinator of the panel of experts on geological heritage of the European Federation of Geologists. Hello, Monica.
Good morning. Hello.
And our project speaker, Chris Peasons. He's a geologist at the Geological Survey of Belgium. Hello, Chris.
Hi, everyone.
And our moderator, Andrei Botin-Dumitriu. I'm sorry, I'm sure I pronounced that wrong. From the Geological Survey of the Netherlands. Hi, Andrei.
There's no problem. It's a long name, Bocin. Thank you.
Bocin. Sorry.
Nice to have you all here. Yeah, no problem.
Yes, thank you so much for being with us here today, especially our guest speakers. But before explaining how all this will work, I just want to give you a brief introduction of the GeoConnect³ project. So just a second while I put the presentation back on the screen. Okay. So you should be seeing the presentation now. So our project is part of the GeoEra research program, funded through a Horizon 2020 Research and Innovation Grant. And you probably know that we as society, we're strongly dependent on resources coming from the ground below our feet, or what we refer to as the subsurface. And GeoEra has this main objective to contribute to the optimal use and management of the European subsurface. These uses of the subsurface, they're covered by 3 research themes: geoenergy, groundwater, and raw materials. A 4th theme is the information platform, which is the common objective of all of us, to make all the data available online for free for visualization and download. So GeoConnect³ is part of the geoenergy theme, along with some other projects covering different aspects of geoenergy resources. For example, geothermal energy, inventory of European faults, cross-border 3D modeling, etc. But GeoConnect³d, as the name suggests, is a point of connection between all of these projects and others in the other themes as well, in groundwater and raw materials. And we even go beyond geo-era themes to address geoheritage and geotourism, for example, that we will be discussing here today. So we want to provide a robust model that can accommodate all types of geological information. And I will explain a bit more about this in a minute. But first, I would like to say, why are we doing this? So the idea of our project came from the perception that the use of the resources that come from the subsurface will only increase given the changes that we're going through over the next decades, because we want to achieve ambitious climate neutrality goals. So sourcing affordable and clean energy, increasing sustainability, access to water, climate action, and so on. A lot of these goals that we have, like for a better future, they rely on different uses of the subsurface. And this subsurface is ruled by geology. So obviously, geological information will become more and more crucial for good decision making. However, we see that science and policy are not as close together as they should be. On one side, geological information is out there, and our knowledge on the subsurface is constantly improving. But is this information accessible and understandable? And on the other side, the guidelines and decisions about the uses of the subsurface are already being made. And decisions, they will only get tougher in the future if we use it more. So is this scientific information out there being used to its full potential? So we think the answer to both these questions is no. And we want to help close that gap. And to do so, our project involves 20 partners from 16 different countries. And we have 2 cross-border areas, the Ruhr to Rhine and the Pannonian Basin, and 2 one-country pilots in Ireland and Germany. And just a note that this webinar series has some focus on the Ruhr to Rhine area, but you can expect a similar event for the Pannonian Basin area later this year. Anyway, we all share a single goal: to develop and test a new methodology to prepare geological information related to the subsurface in a more understandable way, and make them easily available for stakeholders on GeoEra's online platform. And we hope this will help to bridge the gap between science and policy, especially in subsurface management. But I say a lot about our methodology. What is it about? So we are rethinking the way to present geological information. In short, we're doing this by using the information available in conventional geological maps, 3D models, etc. But digesting this information to make it more intuitive. And we do this by looking at geological features in terms of their boundaries or their limits. We're also incorporating information that usually is not used, but that point to specific geologic manifestations. So the combination of these 2 types of information results in our structural framework model with annotated geomanifestation data. And like this, our aim is to improve geological understanding of any given area. So our project started in June 2018 and will end June next year. The first version of our methodology got ready 1 year after the project started. And part of the testing of this methodology is to get the feedback from potential users, like you that are watching us today, basically. And this is what motivated us to organize this series of online events. And as I mentioned, a similar event will be organized by the Pannonian Basin area in a few months. And we'll also have a final joint event for stakeholders early next year in January. So what to expect today? We will start with the two presentations from our guest speakers, Glenn and Monica, on the topics of geotourism and geoheritage. And following with the GeoConnect³ presentation by Chris to demonstrate how our project is incorporating these themes and helping to promote them. We will then have a Q&A with our three speakers and end with an interactive session using polls to get the feedback from you about what you've seen. So during the presentations, please write your questions using the Q&A button at the bottom of your screen. You can upvote existing questions with the little thumbs up, so we know if many of you have the same question. And to get you prepared for our interactive session later, I want to make a test right now, just to make sure everything runs smoothly. So we will be using Poll Everywhere, and it's very simple to participate. You go to pollev.com/ggeoera900. The link is there and in the comments as well. You registered with your name and you get ready for our test questions. And I know this will take a few seconds, but I'm going to go ahead and open the first question and we see how that goes. So our first question is, what is your background? And if you have a background in geoscience, please specify the area. And we'll see if we have some answers coming in. So we have geothermal, geosciences, tectonics, petroleum seismic mapping. Okay, I see some answers, so that's great. Geoheritage, nice. All right, that seems to work okay. Good. And all of these answers, they will be available afterwards as well. So because this is a test, I'm just gonna go ahead for to the next one. The next question is, where are you based? Please click on the map. And if you're not based in Europe, you can use the one on the top right. I know it's a bit small, but it's just for us to get a visual idea of where you're coming from. All right, that's very nice. Cool. So our test works. You should be set to go for the interactive session later on, but I'll give the instructions once again, once the time comes. So moving forward, because it's time for us to start with our presentations. So I am going to just put up Glenn's presentation. Just a second. So we will kick off with Glenn Burridge, once again, Executive Director of the European Federation of Geologists. And he will start by telling us about geotourism, a prominent commercial and outreach opportunity for geoscience. So please, Glenn, whenever you're ready.
Hi, good morning, everyone. This is going to be a short, but I hope punchy presentation. And what I really like to do is provide a new vision for what geotourism can offer us. So on this cover slide are images of what, especially as geologists, comes to mind when this word is used. But I think there's a far more strategic role it can play in our relationship with the public. If I can move the slide on here. Don't know if Renato, you can nudge it along.
If you click, and now you should be good to go. Hopefully.
Yeah, it's just a bit of a delay, I think.
Okay. Sorry about the delay.
That's all right, no worries. So yeah, they're far more strategic role I hope it can play in our relationship with the public. We live in an increasingly urban, digitalized and artificial world, and we risk detachment from nature. This very point in history when we need to reflect on our relationship with it. Yet, no matter where you go or sit on the planet, geology has shaped that environment. It's not just a pretty landscape, it's the cradle of our very history. So I'd like to present you with some new angles for looking at this topic, and I hope I can spark some thoughts with each of them. Now, London might seem one of the last places on Earth that you would go on a geological field trip, but first lesson, you can do geology anywhere. Now, I'm just going to point out somewhere on here in red, that's London Bridge. Now, for 5,000 or 6,000 years, people have been using that as a crossing point from the continent into the rest of the British Isles. That's because the Thames presents a barrier. They started out just using a ford, then it became a bridge much later on, but it's used to this day. And if you had crossed that in the very earliest days during the Neolithic, you would have seen two tiny little hillocks that were just slightly bigger, slightly higher fractionally than their surroundings. The first has become essentially one of the great financial centers of the world. That's where the Bank of England is and all those skyscrapers of the City of London around it. And the second became a religious center. The Romans built a temple there, and today it's St. Paul's Cathedral. So even the tiniest differences in topography can have huge implications down the road. Now, the story told by historians, even archaeologists, is, as we know as geologists, told in small time. But do we really think that the Parthenon is there by accident? Where does all that building stone come from? And why was it chosen in particular? Everyone's using geology even when they are not aware. Equally, great events. Sorry, got a bit of delay there. A location of great events equally does not happen by accident. They occur in the cradle provided by geology, and they're all great tales by themselves. If you stand at the head of the Sarajevo Zenica Valley, where Archduke Ferdinand was shot in 1914, you realize you're standing not only at a civilizational scene, but a tectonic one as well. D-Day, the greatest seaborne invasion in history, was shaped by geology at every scale, right down to the mechanical strength of the sands those troops landed on. Then key elements of how we feed our minds and our bodies are all shaped by the land they reside on. And some locations, like Edinburgh here, are just tailor-made for being a stage for epic geo-storytelling. And we have some great stories. An Indonesian volcano that led to a flowering of romantic literature in the early 19th century. The 1755 Lisbon earthquake and tsunami that aided scientific enlightenment. How a big Swede, what a big Swede is doing on a beach in Hamburg, and how a town was created by a meteorite impact. And all of this we can also tell at the grand scale of the history of our continent and nations. And here's a very basic version of the economic history of the UK as explained by geology. And what appeals here is not the geology per se, but how we can show people how it shaped our lives at the human scale. We need to bring it home. So I'd like to make a pitch for a new kind of geotourism, one that is multifaceted and starts with what appeals to the human mind. And we've lost our presentation. My apologies, I'm not sure what's happened there. Renata, I'm not sure if you can just punch
Yes,
it back.
I'm on it. Sorry.
My apologies.
You know, it's not a webinar if there are no technical problems. It's
So I'll keep talking. So what
sorry
I'm
about that.
what I'm
Okay.
trying to get across here is there we go. Perfect. Thanks a lot, Renata. Geotourism is multifaceted and it starts with what appeals to the human mind and goes out to these epic stories and brings people back to their senses, the sights and sounds around them. And it can be a passport to a far deeper discovery than the simple ooh, isn't that nice of the surface of the planet. And as the image on the bottom right suggests, and will suggest, you don't strictly have to limit yourself to this planet either. There should be a picture of Olympus Mars coming up. There we go. And in summary, what does that mean for what we can do today? So get in touch with your local tourist authority and offer your help. If you're lucky enough to be near a geopark, go and make some friends. Contribute to knowledge bases aimed at the public, write that story. Geologists know many of these historical links and the way that geology has shaped the human history, yet they're not always written down. Get to know historians, archaeologists and tour guides, work together. And if you see a great opportunity to team up with or boost a business, make that cool. Okay, thanks a lot.
Thank you, Glenn. That's a very nice, positive introduction. Don't forget to write questions and comments for Glenn in our Q&A. And now we move on to the presentation of Monica. Just give me a second there. So Monica, oh, sorry about that. So Monica, she will talk about she'll talk about geoheritage, protecting geodiversity and raising the visibility of geology in our lives. So please, Monica, you should have the control and whenever you're ready.
Okay. Good morning, Renata, and thank you once again for inviting me to this webinar. And yes, I'm going to speak a little bit about geoheritage and geodiversity. And as Glenn said, geology is in fact everywhere. And geoheritage and geoconservation may be one of the keys to raise the visibility of geology in our lives. So Earth is indeed very diverse in terms of geological materials and geomorphological and hydrogeological features. And of course, we have a lot of fossil record. The diversity has been designated geodiversity. No other known body in the solar system approaches the geodiversity of Earth. And probably the major factors that explain this geological diversity are plate tectonics, absent in all other planets of our solar system, except for early Mars. Climate differentiation through space and time when related diversity of physical processes, sediments and landforms, and evolution, creating diversity of the fossil record. So geodiversity supports life on Earth, and thus it has a great influence on biodiversity and its evolution. It is probably no coincidence that Earth, being the most geodiverse known body in the solar system, is also the one where complex life has developed. From microscopic to macroscopic life, geodiversity is indeed always present. Throughout history, human societies benefited and continue to benefit from this geological diversity. Geological resources for the development of their communities and cultural expressions. And in fact, the designation of the stone, bronze, copper, and iron ages for some of the historical periods is an example of how geological resources have an extraordinary role through time. Many landscapes, geological phenomena, fossil locations have always attracted tourists, artists, explorers for their aesthetic, cultural, and spiritual values and artistic inspiration. Empires and civilizations have expanded their territories in search for natural resources, many of them of geological origin, and have also demonstrated their grandeur in using those resources. The Portuguese and Spanish discoveries were also boosted by the demand and trade of those resources, like gold, and the several industrial revolutions were also made possible due to the availability and exploitation of georesources. Geodiversity will continue to bring many benefits to our modern society, and in fact, our way of living could not exist without the Earth's geological survey. These are 12 things that are used in our daily life. This is an image from the Australian Mining Council, and it shows the 12 things. They put out 30 things, but I chose these 12. And all of them need geological resources to be produced. So geodiversity is also a reflection of geological phenomena like natural hazards that shape our planet and the lives of its inhabitants. Although their impact may be one of destruction, new environments are also created, thus enabling the emergence of life and new opportunities for us humans. When we taste a port wine, for example, or a Pinot Noir or a Freixigante, we experience the contribution of geodiversity to these extraordinary nectars of the gods. In fact, the variety of the world terroirs are controlled by local geodiversity, offering us exceptional wine regions and wines. See how different are the landscapes in these photos. On the top left, we see the Douro Valley landscape in Portugal, famous for its port wine. In the middle, the terroirs of Burgundy in France, famous for the Pinot Noir and Chardonnay. In the top right, the landscapes and cellars of Tokaj region in Hungary, famous for the sweet Tokaj Iasu. In the bottom left, the mountain landscape of Veneto in Italy, famous for the sparkling Prosecco. And in the bottom right, the vineyards of the Pico Island in Azores, Portugal, famous for the volcanic origin Freixigante. So Europe is indeed blessed in terms of wine regions and terroir diversity, as we can see in these wine regions maps. Europe's wines are well known and enjoyed throughout the world. Geodiversity gives us the wines and also happy times. So geodiversity hasn't got noticed by the TV and film industry as well. Many filming sites are chosen by their beauty, natural grandiosity, cultural, spiritual, and historic associations. Who remembers the successful difficult word TV series Game of Thrones that captivate millions of viewers around the world? These magnificent landscapes in the series made these tales of good and evil more extraordinary and became under the spotlight of the tourism industry. So here are some of the Game of Thrones filming locations. The Vanachakul ice cap in Iceland, the Azure window in Malta, now destroyed, unfortunately, by the ocean, the Meteora in Greece, the Itzurum beach in Spain, it was the Dragonstone in Game of Thrones, the Northern Ireland and landscape, and the bridge between Europe and North America in Iceland. But what happens when geologists are drawn to a series which is set on the fictional continents of Westeros and Essos? We get a geological map, of course. So, as said before, geodiversity is a source of social development, leisure, well-being, and inspiration. So even if it is not noticeable, society assigns it a value. The values of geodiversity can be referred to as geosystem services, the geological equivalent of the ecosystem services used by ecologists. These geosystems may be divided in regulating services, for instance, flood regulation, supporting services, for instance, for habitats, provisioning services for energy, cultural services like geotourism and leisure, and knowledge services like knowing the history of the Earth. Although our society depends on geological resources to its development, there is also a need to preserve those parts of geodiversity that are important for reconstructing Earth history and the evolution of life on our planet. These parts of geodiversity that need to be preserved are defined as geoheritage or geological heritage. By conserving geoheritage, we are also preserving human history, allowing us to acknowledge and understand our place in the history of the planet. Implementing geoconservation measures on geoheritage sites prevents their destruction or damage and allows to preserve special places that are of scientific, cultural, and aesthetic importance, and that play a crucial role in outreach, education, and training purposes. This photo shows the ancient city of Pompeii, destroyed by the Vesuvius volcano at the back. Preserving this geosite, it's important to remember the history of the planet, but also the impact of the geological process in our civilizations. So geosites are like pieces of a symphony, the symphony of the Earth, and geoscientists are the Earth's musicians. There are two main international programs of relevance to geoconservation: the World Heritage Sites and Global Geopark. Both are promoted by UNESCO as being closely beneficial to society. The two maps that I'm now presenting, focusing on the European territory, identify a multiplicity of geological, natural, and cultural sites listed in these two international conservation programs. But these spots on the maps are not the only identified European sites with geological importance and the need for geoconservation. Each country has an important role in terms of geosite characterization and protection in order to preserve these precious time capsules. So the geological map of Europe shows us the great geodiversity of this continent that is reflected in its amazing and different landforms, landscapes, and geoforms that we can admire, in the geological resources that we can use, in the physical processes and geological phenomena that we may witness or learn through the geological record. So I invite you to travel in time, visiting some iconic European geosites and admiring Europe's outstanding geodiversity that have attracted throughout time large numbers of visitors and inspired many legends and tales. So let's start our journey on Iceland. The bridge between Europe and North America in the Reykjavik Peninsula is where we can cross between Europe and North America over a major fissure, which provides clear evidence of the presence of the diverging plate margin and witness the impact of plate tectonics. Flying to Ireland, we arrived to one of the most visited tourist locations, the Cliffs of Moher. These cliffs display a spectacular example of an ancient infill marine sedimentary basin. The Cliffs of Moher are also home to the large colony of nesting seabirds on mainland Ireland. Our site is now amazed by the spectacular exposure of some 40,000 large, regularly shaped polygonal columns of basalt in perfect horizontal sections, forming a pavement. This dramatic geosite is the well-known Giant's Causeway, formed 60 million years ago by volcanic activity, and has inspired legends of giants striding over the sea to Scotland. Following the giants, we land on one of the most famous and important geological sites in the world, as it usually contributed to the development of modern geology. The famous geologist James Hutton unraveled the mysteries of the nearly vertical sedimentary rocks of Silurian age, mainly sandstones and mudstones, covered unconformably by a younger sequence of red sandstone and breccia. Hutton used Siccar Point to demonstrate the cycle of deposition, folding, erosion, and further deposition that the unconformity represents. This geosite proves the enormity of geological time and the antiquity of the Earth, in contrast to the biblical teaching of the creation of the Earth. So traveling further north, we arrived at the mighty Briskdal Glacier, a western arm of the Geodiversity Glacier, the biggest one on mainland Europe, and protected as a national park. It was formed approximately 2,500 years ago and rises 1,500 meters above sea level. The glaciers has formed the Briskdalen Valley with its landscape of smooth rock covered in lush vegetation over thousands of years. The magnificent scenery is among the most beautiful in Norway, and tourists have been visiting the valley for more than 100 years. Near Alson lies the UNESCO protected jewel in the crown of the Norwegian fjords, the Geiranger-fjord. It is a fairy tale landscape with its majestic snow-covered mountaintops, wild and beautiful waterfalls, lush green vegetation, and deep blue fjord. The area's unique natural surroundings were created during a succession of ice ages when glaciers carved out deep fjords and shaped the high mountains. This is indeed one of the most spectacular places in the world. So let's pack our bags and fly to Wiedliska and Bochnia Royal Salt Mine in Poland. This deposit of rock salt has been mined since the 13th century. It has royal status and is the oldest of its type in Europe. The mines illustrate the historic stages of the development of mining techniques in Europe from 13th to the 20th century. Both mines have hundreds of kilometers of galleries with works of art, underground chapels, and statues sculpted in the salt, making a fascinating pilgrimage into the past. The greatest treasure trove of Poland was formed over millennia through a combination of marine deposits and unimaginable tectonic forces. So we arrive now to the Plitzevich Lakes National Park. This area is part of the Dinarids karst region, one of the most impressive karst landscapes in the world, marked by specific geological, geomorphological, and hydrological properties and formed in the Mesozoic age. The karst relief is primarily tied to carbonate rock due to its strong sensitivity to chemical and mechanical weathering and the influence of tectonics. The process of tufa formation, which in turn forms tufa barriers and creates the lakes, is part of the outstanding universal value for which this national park was inscribed on the UNESCO World Heritage List. It is home to a diverse and rich fauna and flora. And we are now on top of the Alps. The Swiss tectonic Arena Sardona presents an exceptional and dramatic display of mountain building through continental collision. During the formation of the Alps, huge masses of rock from very different eras were pushed on top of each other by the Glarus thrust, the so-called magic line that is visible from afar, here. This enables older rock to rest on top of younger ones, and this happened to 10 to 20 million years far below the former surface of the Earth. This area is of great value for school and research as it bears witness to processes of mountain building and plate tectonics. We fly now to Santorini, the idyllic Greek isle sought by tourists from all over the world in search of its sensational sunsets, colorful beaches, and beautiful buildings. Located in the Aegean Sea and part of the Cyclades island of Greece, it is the most active of the volcanic islands, displaying a spectacular caldera with new islands in the center representing the active volcano. Santorini's big one occurred during the late Bronze Age at the height of the Minoan civilization, which dominated the region from 2000 to 1450 BC. The ruins of Akrotiri testify the powerful eruption that may have killed 20,000 people, I'm sorry. So we arrive at the Arouca Geopark in the North region of Portugal. Here we discover the secrets of ancient times where giant trilobites dominated the seas. The outstanding examples of trilobites and other invertebrate fauna fossils were discovered in a slate quarry and since the beginning were preserved by the family company. They were first believed by the workers to be beings from the biblical flooding, but are in fact fossils of arthropods that lived in the ocean that bordered the continent Gondwana 465 million years ago. These trilobites are among the largest in the world and are in perfect state of preservation. One of the most emblematic geosites of the Aroca Geopark is the Pedras Parideiras, or Birthing Stones geosite. This represents a unique phenomenon in the world. It is a nodular granite that presents a rare amount of biotite nodules with a discoid and biconvex shape, markedly aligned. By the action of erosion, those nodules are released and accumulated in the soil, leaving in a granite a cavity whose walls are covered in a biotite layer. So the inhabitants of the Castanheira village call this a rock that gives birth to stone, so commonly known as Pedras Parideiras. We are walking now by the shoreline of Porto, and we come across a unique and exquisite rock. This beautiful rock is an igneous breccia that was formed by a granite intrusion 219 million years ago, and includes fragments of older metasedimentary and gneissic rocks from the Precambrian Foz do Douro metamorphic complex. And crossing the Atlantic, we arrive to one of the most beautiful places in the world, a precious jewel in the middle of the Atlantic Ocean. The outstanding Fogo polygenetic volcano caldera is the youngest and smaller collapse caldera of the São Miguel Island. It is also the wildest and less humanized one. The Lagoa do Fogo intracaldera lake is a major water resource historically affected by volcanic eruptions. So we end our time travel for today, but many other sites are waiting to tell you their stories. Thank you.
Thank you very much, Monica. Such amazing places, and just gives me this wish to travel right now, but difficult in these times.
Yes.
But thank you so much, Monica. That was very interesting. Please, everyone, don't forget to send your questions to Monica in our Q&A. So we're gonna move on. Let me just do my bit here with sharing the screen. And now we will finalize with Chris, and he will talk about tackling the fundamental blind spot. Can geology be explained and understood intuitively? So please, Chris, whenever you're ready.
Thank you, Renata. Yeah, of course, great thank you again to our two guest speakers of today. And with that, I want to emphasize how difficult it is to speak after these two speakers. We've had some email discussions, just to illustrate, we've had some email discussions before these presentations, obviously. And these two people, Monica and Glenn, were throwing quotes on geology and on geoheritage to each other that they found in the great literature. No way I could match that kind of knowledge but I did my best. I did my best not by reading books, but by listening to the radio. And when one of my greater or more one of the singers I really liked popped up, actually I found her singing about geology. And I would like to start with that. The singer is, let me see. Yeah. While we wait for the slide to come on, the singer is actually Peggy Lee, and yeah, here we are, and she sings one of, I mean, if no matter which girl whispers this line into my ear, I'm sold, absolutely. But the big question here, actually, for me is something, a quote like this, or a reference to geology, what does it mean to geology? Does this help us to talk about geology, because obviously there are a lot of interesting aspects to this. This is a great singer. She's very attractive. She sings about geology. Yes, but that raises certainly some curiosity and some interest, but does it actually help us to discuss geology? For example, will you be able to discuss more readily geothermal energy or groundwater because geology pops up in a song like this? And I'd like that may look like a very strange introduction here, but I think it comes very close to the way we look at geoparks and about the very nice geological examples that are out there today, or that we have, and that Monica and Glenn have shown us around. Let's, for example, just forget about the singer and let's replace her by a volcano. And you may recognize this picture. I've been learning a lot from the presentation of Monica for mine here. Obviously a volcano is also a great singer. It's also very attractive, and it also tells something about geology. And when you look at the volcano, yes, you can discuss about the volcano and about volcanics, but does that help you to link to shale gas or to groundwater? That is actually the big question we will try to deal with here. So this is from curiosity to interest, but in order to go one step further, we actually would need to go to an actual understanding as well. And what I've done here is I've picked 3 of the sites that Monica showed. You will see here left to right, Iceland, the bridge between Europe and America, the Alps, where you have the big trust, and on the right, the karstified geopark in Croatia. And see if we can come from this, just from a nice picture, to actually that's a little bit deeper, a little bit more meaning here. And as Renata already said, the way we go about this in the project, not specifically for Geoheritage, but as a general way, is we'll take geomanifestations, and these 3 we can look at them as geomanifestations, just special things pointed to some kind of process, and put that into a structural framework that would give us a little bit more context. That sounds very technical, but I'm going to try to make this as intuitive as possibly can be and see how that works. Just about geomanifestations, Monica has taken us on a big tour, and I think all the yellow stars that you can see here are actually sites that she mentioned. All the dots that you see here are things that we wrote about in our project. And these are just a couple of the pictures that you will find on the internet if you look for our blog site, and where basically everybody in the 20 partner team has actually actually the opportunity, or well, we've asked them very politely and very insistently to write about the nice geology in their country. And there's a very nice and very extensive set of stories there that you can, that's an alternative route to visiting Europe once we are allowed to travel again. And in the meantime, we can just prepare for that. So these are just the geomanifestations in the blog, and I want to point to that. But let's think about the bridge in Ireland, where they claim, oh, that's a bridge between Europe and North America. If you take an atlas, you know that the line between America and Europe does not run in Iceland. So let's just look a little bit at that claim first. And in order to do that, we'll take a couple of slides to build up a map of Europe using our structural framework. These are just the countries. If you look at the important boundaries current day, the plate boundaries, then these are the current plate boundaries that you see. I'm showing it in this order. The boundaries, or what we call the limits first, you can obviously fill them in colors and give them names, and then you see the current plate tectonic units popping up. That's a very boring picture to look at. I mean, nothing much is happening. It's just one gray area, which we call Eurasia. But we can dump other information on top of that. These blue lines are older structure zones, so past plate tectonic boundaries. These are, I'm drawing up a little bit more information here just to see that you can stack them up until the red ones are very big faults, until there is no sense anymore to make of this because everything crosses and you need to structure it again. And you do that by coloring again the units in between them. And if you take the suture zones, the blue sutures, and you use them to define the old pieces, then you basically come to the building blocks of Europe, or our part of the world. So these are all the small plates, macrotectonic plates that shape, that have drifted together and collided to form what we call now Europe. These are the plates. Since we call them suture zones because that's where the plates have merged and have become too stuck together. Each of these suture zones represents an origin as well, because that's where they collided and that's where they deformed. We can start filling them in here as well. And if you look closely enough to your screen, you will see the hatched areas, gray hatched areas appearing here. And they're a little bit all across Europe. We only did the one from the past 600 million years, so that's why Baltica is not really popping up. But basically, you've got 3 to 4 big groups of these origins that have shaped Europe. And these are quite important to see. These are also some, especially the Alps and the Veriskides are the ones that are going to pop up later. Now, importantly is that we see here in the east the Uralites, or the Ural Mountains as they are called geographically. Because these help us actually to get the missing boundary that we had to define Europe. These are the 3 boundaries. You've got two plate tectonic, active plate tectonic margins to the west and to the south. To the south, the African plate margin, and to the east, you have the suture zone, which is the Uralites, and everything in between. Geologically speaking, this is the definition of Europe. It's a scientific definition, and one that I like because I'm a geologist, and geology should come first. Now, let's explore, with having done this definition, the claim of Iceland, that there you can walk between the continents. And yeah, let's zoom in a little bit to Iceland. And actually, the yellow star will show you where the bridge is. That figured in Game of Thrones. Let's check here. Yeah, there it's coming. And you see indeed that it is sitting on this Mid-Oceanic ridge, because Iceland is a very interesting and very unique island in the world. It's actually where the Mid-Oceanic ridge pops up. And indeed, since we have proven that Europe is a fact, and that the boundary of Europe, it's not whether Iceland is not either in or outside of Europe. Actually, Iceland is only half part Europe and half part North America. Yes, there is a point there and a very nice gap where you can cross from Europe to North America, and fortunately also the other way around coming back. So is just a fun way of looking at the geology of Europe to claim this fact. And I hope it's a little bit different to story and tell now than just go to that location in Iceland and having to believe actually that this is a bridge between 2 continents. There's a whole story behind it, and that's what we try to show here. Okay, let's do some other more fact checking, and let's go to the second location, which is not in Iceland, but in Switzerland. And that's where the, just giving a little bit of background there, in the 19th century, there was a big debate about what an origin actually was and what the most prominent features in that origin were would be. Again, the yellow star, and I think the picture should come up as well. Let's see, one more click maybe. Yes. So this is also again a picture that Monica showed, and they thought, well, again, we are looking at the suture zones, continents collided, and the most intuitive idea you probably have is that rocks start to crumble and fall like two cars smashing together. In 1884, Marcel Bertrand said, well, that's not actually true. The most important features are maybe not the most obvious ones. It are these thrust sheets, and these are the base of the nap faults. And one of these faults is shown here actually in red, and it's called an arena to actually look at it. You can, if you would zoom in a little bit on the picture, you can actually see different types of rocks lying on top of each other across a very, very narrow border. But that border is actually a thrust sheet. And Switzerland says, yeah, this has been discovered in the Alps. So everything is nice and everything is good here, but I will contest the fact that it was discovered in the Alps. I mean, the Alps are very nice mountains, but that's not where this concept actually originated. So because Bertrand in 1884, he wasn't Swiss, he was French. And he had been in contact with another French guy, Gosselet, in 1880. And Gosselet wasn't active only in France. He actually had come to a symposium in Belgium, and quite a bit earlier, actually, by Corneille Briard. And these are the guys who defined the thrust sheet. And you'll say, what were these guys saying about the Alps? They weren't saying anything about the Alps. They were saying something about a much older origin, which is the Variscan origin. And again, if you have the Alps in the south, then basically everything north of that, up until halfway Belgium, are the Variscan origins. It's not an origin today, but it are still the roots of that old origin. And that is where, wait, let's fly there a little bit while I give some background. We don't have that nice arena anymore, but what these people had were the coal mines in that area that allowed them to have the same 3D view there. And you see here in blue actually the Variscan front running through, and it's at this Variscan front that they were working. If you zoom in further, then you will see that the Variscan front splits up into different thrust sheets themselves, and these were the ones that were encountered there. Unfortunately, I didn't immediately find a very nice picture to show here, because you can find these faults in the field, but not in as spectacular way as in the Alps. So you're allowed to go to the Alps to actually see all this, but just get your facts right. And it's in Belgium. It's Belgium that actually invented nap tectonics. And then let's go to the third spot here. And I will try to do this very, very snappy here to stick a little bit to the time schedule. You certainly still remember this nice picture here from Croatia. Croatia is a little bit too far from my home, so I'm gonna take it to, well, a very nice small, but a little bit smaller geopark that we have in Belgium, also in karstified limestones. And I want to do it to show that how the structural framework, which we're showing here, actually links how you can embed other information into that to give it a little bit more understanding and context. So you have here the Variscan front. You're here south of this. This is all have been deformed. This is your Variscan origin, way down to the Alps or to Italy. And we're going to look at this band here. And you can see it's very wiggly and very irregular. That's actually around that band, which is a band of limestones. That's where the geopark there has been profiled. And what you see now is actually the map of the geopark being transposed or as background to the geopark. And this band, that's the one that actually maps more or less, or matches more or less with that part. You can also tell a lot about the groundwater here and how it flows. But what I want to show you here, and is because also it's one of the nicer features that the people from Geopark pointed out to me, is you've got this very irregular bend. You can ask yourself why? Well, the reason is, and this is in the Variscan origin, this all has been folded. And there are a few places where you can actually see this. This is one of the nicer anticlines here. I see, do I have a trace here? Let's see, no, there the trace has disappeared for some reason, but you could see here that this was actually anticline folding in like this. So it's a very nice place, not just to look at that, but also see at the formation of those rocks. And in one of the next sessions, we will actually come to limestones, not just for freshwater, but also if you bury them deep enough, or if you find them deep enough, 3, 4, 5 kilometers deep, the fresh or cool water is being replaced by warm water, and we talk about geothermal energy. But keeping this, we just want to conclude on this message here. So what I try to do here in this presentation is come from the very nice points of interest that immediately grab a public's attention, to see how we could give a little bit more information and background to that. For Iceland, how we could actually link it to the large-scale geology of Europe, how we could talk about the Alps there and talk about immediately at the same time about the unknown and hidden origins that are really at the underlying the largest part of Europe, and how you can, inside that part, you can come to a geopark and talk actually about the faults and demonstrate them and see how they play a role as well. And all of this, although we're still in a maybe a little bit sketchy and we're still in the early part of the project, but we hope that this is actually a test to see how effortless we can make that jump from nice pictures and nice show places to some deeper understanding and deeper discussion of the geology. Okay, thank you. Over to you, Renate.
Thank you, Chris. Context is everything. So thanks for that nice take-home message. So please don't forget to write your questions to all of our speakers. I do see that we already have some questions popping up. So now I hand over to Andre, who will take care of the Q&A session.
Yeah, thank you very much, Renata. I thank you for the very interesting presentations. Yeah, just a small update on the attendees. We are almost reaching 100. Yeah, to tell you the truth, we are 93, but it's still very close to 100. With this, I have a couple of questions and comments. I think the most important one from an administrative point of view is, yeah, some of the attendees ask about the availability of the slides after the webinar is closed. So Renata, if you can comment a little bit.
Okay, for sure our slides will be available. If our guest speakers agree, we will make theirs available as well. Is that okay, Glenn and Monica? Okay.
Okay, then
Okay.
we got very pleasant reactions about yeah, the quality of the presentation, and also that it's very interesting. But going now to the question, well, we have a question from Jayesh Desai. I hope I'm pronouncing the name correctly, otherwise I can understand your pain. The concept and initiative of geotourism is very important. In India, the geoheritage sites are looked after the National Agency, Geological Survey of India. Sadly, they are looked after very poorly. I would like to promote this whole platform in India. Please guide me. I mean, Glenn, Monica, Chris, do reach out to Europe after after seeing, you know, so many people coming from the other side of the world.
Maybe I'll just dive in there and say that, of course, this is applicable everywhere in the world, and maybe it just shows again that it's a grassroots thing. Yes, ultimately, we love authorities to be able to provide the facilities and perhaps financial support and obviously coordination. But there's a great deal that we can do as individuals, and that was part of what I was perhaps trying to get across. And so it's wonderful if there are panels and exploration and explanations on these sites. But actually, sometimes the most powerful thing to do is to simply take people there and tell the story in person. And I know that's difficult at the moment, but in the time frame of a year or two, and in some places already, this is possible today. So I guess that would be the encouragement I would give.
Thank you, Glenn. If there are no other questions, I'll move to the next question. I think we have to put this one because it tells also about the nature of the event that we organized. Mohammed Majid Zarai. Do we receive a video and a certificate of attendance? So there are two questions in one. I think about the video, Renata.
The answer for certificate of attendance is no, I'm sorry. We didn't really think of that. But as for the video, yes, it will be available. We're now live streaming to our YouTube channel, and the video will be available there. So we will post the link to the YouTube channel in the comments very soon. But yes, so you have this available. And I think through Zoom, we can also make it available for download. I'm not fully sure. I'm not going to promise, but if we can, we will.
Yeah, I think I'm going to promise on your behalf, Renata, because that's how the things function with Zoom, I think. Thank you for the answer. I hope that we answered the question. We have also a really nice comment from Arjan van der Star, who says that recently visited Lindisfarne, Hadrian's Wall, Carlisle, with students to teach them about interdisciplinary science. They quickly learned that geology is the basis for everything. This is very much in line with your presentation, Monica, and your presentation, Glenn, and also I think this connects very well with your intention, Chris, because I think education is a very important aspect of it. And then my question is, do you see the framework that we are building contributing to education programs and syllabus and so on? Can you please comment on this? Of course, Monica and Glenn, you are also very much welcome to comment about the education side of it, not really the scientific side, because yes, we are all, powered by the scientific, but education is also very important.
Yeah, I'll maybe start with a quick answer to to how we see it developed from the project. As Renata said, we weren't actually going to do this when we thought about the proposal, but we see that we've created something that actually allows very good to communicate about geology. And we've already have actually students coming to work here with us to do their part in it, to study like that. And we have an invitation already, or we invited ourselves, that's the more honest way to say it, ourselves to give 2 lectures next year to bachelor and to master students in geology, explaining them using structural framework, explain the geology of Belgium and see how that compares to their standard lessons. And we have some quite concrete ideas to actually take it even an educational level lower and go to schools and try to tell something about geology there. So yeah, we think we can, with this tool, we can actually go from that low level, or well, that low starting level of geology, to actually discussing the things with experts, which we have done as well. When it comes to the caledonites, for example, we've had expert meetings, which worked very well as well, with basically the same kind of tools.
Okay, I found this also inspiring. Monica?
Yes, I was going to say that, in fact, field trips are, of course, powerful ways to explain geology to students and to other public. I do many field trips in my PhD area, the Forstdorp Metamorphic Complex, for students, for instance, from basic and secondary schools. And I think it is very important for them to see the abstract concepts that they learn in the schoolrooms, and see the rocks in their natural environment, understand their formation, understand the structures. And this is a way to visualize what they learn from books and from the teachers. And I think in the future, there are going to be citizens with very much, a good knowledge of what is geology and the importance of geology in our society. So I think it is very important to take people to the sites and to explain, to tell the stories of that rocks, so that they really understand what they are looking and studying.
Thank you, Monica, very much. Just brushing to the questions, because they are popping out like popcorn right now, which means everybody enjoys it. How do we get connected in a forum which allows interaction with other like-minded people who want to promote this successfully? Are there studies and information on what is successful and draws people to Geoheritage? I think, Glenn, you have a word here, but also I have to specify that I will post here the links to all the social media that we have, and I think that's a quite good platform for actually interacting with the GeoConnect³ people and the GeoConnect³ program. So, Glenn, I think I was thinking about you to answer what is successful and draws people to Geoheritage.
It comes back to the human story, doesn't it? In the first instance, if you're not a geologist or even a scientist, I mean, let's face it, a lot of other scientists don't know very much about geology. It's always surprises me, and I think sometimes they're the first people we should try and share the geological story with. But in terms of the general public, either, it's a two extremes, so that the epicness, or it's something that's connected with their lives. And the easiest thing to do, particularly if you're taking this view, I guess, that I was trying to promote, that geology is everywhere, you start with the human side of things, because that's something which taps in to every location on Earth, pretty much. And certainly, in the urban environment, and that's where geology often seems so distant, but it's still there. And so that's, at the moment, I come back to those first images where we're trying very much to plow on with this sort of the attraction being the epic. And I think the side which we probably need to pay more attention to is to try and show that it's pervasive everywhere. And if you look at some of the very powerful and effective methods that are used, for instance, by biology, a TV program's about how you can find things in your own back garden. We have a very successful TV series in the UK based around the various seasons, and people, are really contributing to that with citizen science, for instance. So we need to learn the tricks of the trade of how to do that, and to obviously continue to play on the epic nature of things, but to really bring it home to how geology is with you 24/7.
Yeah, that makes me almost trying to go back to my studies. Seeing all these presentations, I have a very maybe the final questions. We'll try actually to answer to all the questions that were posted here. It's from Haydon Mort. Can I ask what is the general feeling amongst the panel? Is the designation of geopark designed to attract curious, more outdoor people, or the masses who have no particular interest in the earth sciences? If the answer is both groups, I think we may need to do more to attract the disinterested majority of the population. So I think this really appeals actually to the bones of this project, because it's really that buffer zone that really the trying to escape that bottleneck. So repeating again the question, maybe Chris, you can answer. Although it's about the geopark, maybe you can extend it to GeoConnect³d. Is to attract more curious people or outdoor people or passionate people, or is for the larger public?
Yeah, well, I'm not going to give, I'm sure that Glenn and Monica will have a little bit different way in really talking about the geoparks. But in general, indeed, our biggest struggle, and that's why we're really very happy to see so many people online, for example, now, is how do we reach out to the people we think are our stakeholders? Because and how do we make them listen? How do we talk to them? And that's why we actually developed something that we think we can actually use them to talk with them, interact with them, without them having to leave their comfort zone or having to learn something about geology. It should come quite intuitively. And I think that's also something we could force, or we could use at different levels. And yeah, I mean, people who are interested, that's always easy to talk to them, but I think we underestimate how big that group actually is. It's really about getting the story right, and once they find that small connection, if you can work on that, I think a lot is possible. But when it really comes to geoparks, I think both Monica and Glenn are much better placed to answer.
Yeah, thank you. So I think this wraps up our Q&A session. So moving to you, Renata. But yeah, we'll try to reply to all our questions after the session.
Yes, thanks, Andre, and apologies to everyone because we want to stick to our 1 hour and a half that we promised, so we cannot go through all the questions. But I think a lot of these comments they addressed. I hope. I see things are frozen, so I'm not sure if people are listening.
No, you're not frozen to me, Renata.
Okay, good. Sorry about that. It just froze a little bit here for me, and I was a bit scared that I was talking to myself. It happens. So as I was saying, if we left questions unanswered, we will do our best to get back to you individually, because we have your emails and everything through your registrations. But obviously also don't hesitate to contact us as well. You have the GeoConnect³ email. So we will be very happy to hear feedback and hear more questions as well. But I will move on to our last bit of our webinar, which is the interactive section. And I hope that you know, although it's very difficult to talk about these themes in such short time, but I think our speakers did an amazing job by showing some very, you know, nice aspects to it. So now we're interested to know a bit about your impressions. So for who wasn't here at the beginning at the test of the interactive session, so it's very easy. You go to paulf.com/ggera900. You have the link in the comments as well. So you register with your name and you answer not the test questions. I'm sorry, this is wrong, but you answer our questions. So I will go ahead and open the first one, and we will see when the answers start to come up. So you've seen in Chris's presentation that sort of like undressing Europe and trying to rebuild it back. So I have this phrase there: the way GeoConnect³ presents geological information is easy to understand. And you can be honest, we will not be sad, but we're interested to know. Obviously, it's very hard to explain, you know, the geology of Europe in a couple of slides, but that the way that we're trying to do things by focusing on how are they limited and filling things in between, if you think this might be an easier way to see geology. And I see a strong agree, which is very nice. And I also invite our guest speakers, Glenn and Monica, to participate as well if they want. And you can also comment if you want, of course. But I am happy to see that the majority agrees with this phrase. So this is nice. And maybe I'll just quickly ask first Monica, because for you, GeoConnect³ is a completely new thing. You probably heard about it just when we reached out to you to give this invited presentation. So what did you think of what Chris presented? Did you think this contextualizing or this contextualization of geoheritage sites, for example, is this an interesting approach?
Yes, I think it may be an interesting approach for geoheritage. And of course, as you said, I only get in touch with GeoConnect a few weeks ago. Yes, but I see also your methodology, the geomanifestation, is a very catchy word for the geological phenomena, and I think it will be a nice input to explain geology to other people. Yeah.
All right. That's nice. Thank you. I'm going to move on to the next question because we still have a few, and I'll ask for more comments. This is more of a general question, not specifically project related, but we would like some ideas on how to better communicate and promote geoheritage and geotourism, because we at GeoConnect³d, we have our project objectives and everything, and we're trying to, provide this geological context that hopefully is useful for people in geoparks or people that are involved in geoheritage. But we would like to hear more from you that are watching us. What do you think? So virtual field trips, that's actually very nice. And it's something that with the whole COVID-19 situation, it also got more how do we say? It got more popular as well, right? As alternative to fieldwork. So we have getting geology into school curriculum. Yes, we totally agree with that. And field trips, geological guides, real field trips, of course. But yeah, virtual field trips is actually quite popular. So that's nice. And we have all of that's very nice. So many ideas. I love it.
Yeah, there are very few bad ideas, I think.
Yeah,
if there are
that's
any.
great. That's very nice. And again, this will be available for everyone to see afterwards. But because we're quickly running out of time, I am going to jump to the next question. And this will be like a quick one, but what are the pros and cons of the geo-connected way of presenting information? So that what Chris showed in his presentation. And please indicate if you think if it's a pro or a con. So we'll see if we get a few comments on that, at least, hopefully. One comment pro, so maybe that's like overall approval of the method. But if you have specific feedback as well, obviously this is work in progress. So what Chris showed, as he said, there's still, tuning and refining to be done. Map-based is good. Logical progression of ideas to explain complex geology. Make it less technical. Yes, this is actually a very good point, and I saw this in the questions as well. And the good side of GeoEra as a whole as well is that we're working with project vocabularies where we define each of the elements that we're presenting. So we have a sort of vocabulary level that is out of jargon as far as we can. So this is something that we take a lot of attention for sure. So we really appreciate that comment, and we need to refocus a lot because we tend to go to jargon very easily. But nice, we will check your comments later on. I'm going to move to the next question. And again, some ideas, if we can get on how to make geological information even more understandable. So we all think that we need to communicate geology more and better. But I would say that avoiding jargon is one of the ways of making it more understandable. Clear 3D images. And it's true because we're often very bad at seeing things in 3D, let's say, especially if we're talking about the subsurface. It's something so abstract. I would like maybe a quick comment from Glenn. Do you have, I know you have a lot of ideas because we discuss a lot, but do you have like a quick idea on how we can make geology more understandable?
Ooh, yeah, it's a big question. I think learn from other sciences and disciplines that do this well. There's often, there's some tricks you can use, sort of start with one big idea and then fan down to maybe 3 things. Always remember that the human brain can only deal with absolute maximum of 7 things at once. And that includes the syllables in words. So yeah, I think it's about, I mean, like you've got with your structural framework there, you've got this idea of, a kind of zoom in and out. And the fact that often the brain works quite well when you work from the outside in. You start with something very simple like the Earth and then zoom in selectively. Don't just hit people with 12 things at once, doesn't work.
Yes, that's very true. And I really agree as well with learn from sciences that do it well. This is a very good point. So, okay, moving forward to the 2 last questions. So first, what did you like most about this session? This is on purpose, sort of leading you in a positive way. But yeah, we're interested to see what appealed the most to you that are watching, and what was the most interesting. And we see if we have few comments on that. And I know we're almost running out of time, but we're really almost done. We'll stick to our 1 hour and a half, hopefully. So there's some comments there. Interesting presentation in discussions. I agree. The presentations were great. Learned about new geological sites, which is very nice. Actually, for me as well. Could participate from home. That's the good side of a webinar. This event would have been a live event, but during the current circumstances, we turned it into a webinar, and it's actually nice that you can reach more people that otherwise wouldn't move to Brussels and participate in an event like that. So thank you for your comments. We will go through them later. And one last question, and you can be honest, we will not be sad. How would you rate the event? And this would be nice for us as well. We have, as I said before, and I will quickly go through in a second, that we have more webinars coming up. So we've learned a few things today to improve for the next days. So a lot of people think it's good, which is great. Some people think it's average, which is also okay. No one thinks it's a disaster. So this is, I take this as a very positive outcome. So this is our last poll. Thank you very much, everyone, for participating. I know it's a bit on a rush. I apologize for that, but it's enough for us to have a good idea on your feedback. So we're reaching an end. And as I said, we have 3 webinars coming up, Tuesday, Wednesday, and Friday. The registration link for each of the events is on the chat and in our social media as well. And I especially invite you to come back to the last one on Friday that will kind of bring all the themes together into the general theme of the subsurface. And this will be very nice. And if you want to keep updated on GeoConnect³d, we are all over social media. The links are in the chat as well. But you can find us on Twitter, Facebook, LinkedIn, ResearchGate, and on YouTube, where the video of today and the other webinars will be available afterwards. So this is it from us. You have our email as well if there are any comments that you would like to share with us. And I just want to quickly again thank our guest speakers, Monica and Glenn. Thank you for your great presentations and for joining us.
Thank you for the offer.
Yes, thank you for the invitation. See you next time.
Thank you, Chris, for your great presentation representing our project. And thank you very much, Andre, for the moderation. And that's a wrap for us. And hopefully see you tomorrow. And if not tomorrow, on Friday. Thanks, everyone.